Assalamu alaikum, I am Omar Mansour and I am going to introduce my project for dynamics course, and my topic is going to be dynamics of curvilinear motion. So at first we can introduce the curvilinear motion and define it as a curvilinear motion is a little complex than rectangular motion, and it can be defined as a motion which occurs for a particle when it travels along a curved path. So this path mostly described as 3 dimensions. So for the position of a particle, a position of a particle is where the particle located on a curved path measured from a fixed point on O. The position vector will be r equals to r, will determine the trajectory of the particle. And for the distance, we can measure the distance by taking the theta, the angle, multiply the r, the radius, so we can know how long does the particle moves from the first path from the first position to the second position. And for the velocity, the angular velocity can be defined as the velocity rate, and the load to use it will be the distance over time. Here's my problem, and the problem says that we have to determine the angular velocity and when will this cooling fan will complete the shelf life. So the knowns here, the angle and the radius and the time, which is 0.02 second. So for the solution, we used C multiply 2 by R to get the total distance for the whole circle, which will be 36 millimeter, and we use this law to change the angle from degree to radian, so it becomes 1.2. After that, we use this law, C equals theta r, to determine the distance from S1 to S2, which becomes 7.025 millimeter. And after that, we use the angular velocity, which will be S over T, S for the distance and T for the time. So we got 351.25 millimeter per second. So after that, we used this law in order to get the total time. So after we get the total time, which is this one, 0.1 second, we can go to another equation and multiply the total distance for the circle, multiply the total rotations that the fan will take in order to that will make it stop working or die, or to complete the shelf life. So after we get this solution, or this result, we can take the total time, T S over V, in second, and then we change it from second to hour. After that, from hour to year, in order to make it easier. So we got the shelf life. So meaning that if this fan completes 8 years continuously, it will complete the shelf life. And thank you.